Hi and welcome back to another Geeking with Jody. This is about C programming language and its keyword. This is not a C tutorial. I don't know what this is. This is a quick review of C keywords to freshen your knowledge and memory or show you some new things in C. This always happens, although C has only 32 keywords, at least the original C. The story is I was trying to sleep. I was sleepless. I thought, okay, let me see if I can remember all 32 keywords and if I can group them. For sure, I fell asleep very soon, even when I was trying to find all the variable types. So anyway, as you know, in C we have different identifiers. You can define variables, name them I or whatever. But you cannot name your variable if, because if is an keyword. Keywords are the main reserved word in the C word. I try to group them in different parts. We have 32 on the original C, but later new keywords added. I have this book always with me, the classic book of the C programming language from Dennis Ritchie and Brian Kernel, the book. And on the first glance, C is super easy because it only has 32 keywords and most of them are super straightforward. But when you start using them on an advanced level, they can become confusing, especially in the cases where you study these 32, you understand them, and then you go and read Linux kernel source. It starts to get confusing. One idea is trying to, in another video, to show you all the more complex one like these ones with samples from the kernel. But anyway, let's do a quick review on C keywords. The first group, which contains 1, 2, 3, 4, 5, 6, 7, 8 of 32 keywords, are different variable types. Integers, characters, integers can be longer numbers, characters are 0 to 255 if they are unsigned, so all are positive, or minus till, because we have this 0 here in the middle, if they are signed. So integer, characters, floating points 12.1, double precision floating points, short and long. You can combine. For example, if int has a range in your computer, you can say I need a long int. It will be longer than your normal. And you can say interpret this variable as a signed variable, so I can have minus sign, or interpret it as an unsigned one. Then you have the loops: for, do, while, and goto. Okay. Goto is not a loop always, but anyway, you can say for this condition, blah, 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 do these. Most of the time we say for int I equals 0, while I smaller than 10, I plus plus, do this. But this creates a loop on this block. Or you can do it with do and while. You can say do this while that. While this condition. Do this while this condition. Or you can use a goto. You can say goto, create a label here. It's one line label. So you can say goto here. This can be a jump. This can be a loop, or whatever you decide. Real programmers don't afraid of using gotos, or not afraid of using gotos. Then you have conditions, if and else. If something, do this. Else, do the other thing. Sometimes you need lots and lots of if and else. You want to say, if my character is A, do this. Else, if my character is B, do this. And other parts. I'm just writing pseudocodes, as you can see. In those cases, switch will help you. You can say switch based on your character, case A, if it's A, do this and add a break here. We will see break a little bit later. Obviously, I'm not teaching C, I'm just reviewing the keywords with you quickly. Case B, blah blah, break, and that then you can say default case is this one. So this is switch, case, and default. So we know about the character types, about the loops, if and else, and switch and case. We just saw the break and continue. If you have a loop here, for this, do this, and you can have a condition says if this condition, then break. It will break this for. So if this condition happens and the loop is working and this condition happens, your code will continue from here because this breaks the whole code. I found my number. I don't want to check the others. And sometimes you can have another if, for example, continue here. In this case, if you have a loop and you reach an if, continue will lead your code to continue the next iteration of the loop. So if you have a loop here in some case, and you reach and continue here, your code will continue the next iteration, will omit these. So characters, loops, conditions, break and continue. We can go to void and return. These are for creating functions. I can say void to do this. I defined a function called to, which doesn't return anything. If I wanted to create a function which returns something, I would say this function returns an integer. So int 2. And then I can say return 2. So when the function is done, it would return a 2. So I could say int I equals 2 function. It would run this function, would return a 2, so my I would be 2. So this is void and return. You know all the basics. Easy. Let's go here. Let's start with this one. These are for creating your personal types. You saw the official types here, but I can do a type def to create a new type. I can say from now on, if I said Jadi, I mean integer. In other cases, you can create enums. You can say I have a new type, enum weekday. It can be Sunday, Monday, blah 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 till Friday and Saturday. Now your variable weekday can be only one of these. This is for helping you to write more readable and cleaner code. You can also use the struct to create a struct. You say struct person, I have a new type which is called person, and it has an age. It has a, for example, of type int, of type group of characters, name, it has a job, blah 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 blah. Then if you create a new person and call it Jadi, you can say Jadi's age is something. Jadi's name is Jadi. Jadi's job is something. Please subscribe. I want to change my job to this. This is so fun. Anyway, so you know struct, you know type def, you know enum. Let's go for union. Union is kind of look like struct on the first glance. You create a union, give it a name, and then you say int I, float f. But later, if you define a variable like number of this type you just defined, you can say number I is 5. But if you change the code to say, if you add the code that say number f is 12, you cannot get this 5 back anymore. On your unions, it's a union. Only one of these can be used at the same time, at each time. Very strange thing, but super useful when combined with structs on the, for example, Linux source code. I'm thinking about recording another video, so please subscribe if you want to see the more advanced C and show you how people use these unions to auto-convert things to each other, to access bytes of a number, and these kind of stuff. But here, we were able to create new types. Two other, these are the last ones. Let me tell about the size of first. If you have a variable called a, you can check size of a, and it will give you how much a uses in the memory to be saved. How much memory is used to save a. I think this is correct one. This is used for arrays and different kind of stuff, or allocating memory and these things. These are the last ones, at least up to, no, we still have this. So let's continue. Constant defines a constant variable. You can say constant float pi equals 3.14, and pi will be 3.14 throughout your program. Why this is useful? Why you cannot just use a normal variable here? You can, no difference. But when you tell the compiler that this is a constant, compiler can do better optimizations. In the beginning days, people used to write their program in assembly and they were blazingly fast. So C compilers had to start doing more and more optimization on the C code to compete with assembly. Nowadays, I can assure you that 99.99% of the people can write faster code in C than in assembly because of optimizations on the C compilers like GCC or whatever you use. So when you tell compiler that this is a constant value and won't be changed, you're helping it to optimize your value. On the opposite direction, you have the volatile. You say this variable is volatile, and it's called temperature, and it's 32. Later, you may print 32, and it's not temperature, and it won't be 32 anymore. How is this possible? First, you can have specific hardwares. You can have different programs accessing different parts of the memory. So even on some operating systems, you can create a system where you have a variable and set it as 32 here, but you have another program which changes this memory location because it has a real sensor, reads the temperature and writes it here. In this case, you tell the compiler that this is a volatile variable. Don't optimize it at all. Don't do anything smart on it. I don't need any optimization here. Just create a variable. Don't do any optimization because other programs may change it, and I want that change to happen. If compiler optimizes it, maybe just replaces everything with 32. But here you are saying, whenever I told you, go check the exact variable location. So volatile tells the compiler not to optimize these specific variables. And this is our last group. Auto, these are all used when you are defining new variables. Auto is what we always use when we say int I. Practically, we are saying auto int I. This is the automatic variable. Do whatever you feel like with it. Optimize it, don't optimize it, try to make it faster, or whatever. Our normal variables are auto, so you technically never see auto. Nobody writes it down because this is the default. On the other hand, we have the register. Register variables are suggested to be saved in the registers in the CPU. when you have your CPU. This is the hardware of your CPU. You have some circuits for calculation, everything, and you have very few places for internal variables. These are called registers. These are memory locations like variables inside the CPU. They are super quick to use because CPU directly works with them. When you say do this, it works directly on the registers. You don't need to go to the RAM, get the variable, save it somewhere in one of the registers, do the calculations, for example, add 1, then write it again on the RAM. This is normal variable. But when your variable is stored inside the CPU in one of the registers, that would be super quick. So when you introduce your variable as register, you are hinting the compiler to use one of the CPU registers for it. I want to do a lot of things with this variable, so please make it super fast. This is just an optimization suggestion. We also have static and external. Normal variables, you will lose them when you leave the function. If you have a function like int count and you have int c equals 0, c++, add 1 to c and return c. Every time you call this, it will return 1. Because every time it will create a new variable, which is c, add 1, then return it. Then the variable is gone till the next time you call it. But you can say int, static int, c equals 1. This way, only the first time you come to this function, the c will be 0. But it will stay as an static variable throughout all of your source code in this specific file. So if you have a.c, throughout all this a.c, this will stay static, and next time you call it, it will be 2, next time it will be 3. So this is how an static variable works. Extern is the same thing, but works in all different files you link to each other when you are writing your program. So if you are writing your programs in 2 different files and you define your variable as an static, it will work as a global variable here. If you define it as extern, it will work as a global variable in all of the functions. Super cool. And what happened? You just reviewed all 32 C keywords. I added these because these are coming from C99, I believe, and some more. This is not only these ones, but I just wrote down to show you that new things are being added. For example, you have inline, the same function we talked about, int 2, return 2. If you define it as an inline function, technically compiler most probably will just replace it with a 2 whenever it is called. You say optimize this aggressively right now. If you do a restrict, it's kind of part of these. You can say I have this variable restricted. It means this is a pointer to a location, and this is the only pointer pointing to this location. So this will help your compiler to make sure that nobody else is going to use this. So that would be better optimization. Even things like with an underscore in the beginning, like bool, like complex, and these kind of things are being added to the C on C99. Also on C11, which is 2011, we have lots and lots of things, new things here with the same pattern, underscore blah blah. Underscore bool is a data type which can have 0 and 1. What is fun is you didn't see something even like main, let alone malloc, memory allocation here. These are not the C keywords. Things like malloc are coming from glibc. These are the group of different functions used in many C programs. So if you have glibc on your compiler, you can use it. On your operating system, you can use it, for example, to have this function so you don't need to deal with the operating system. Or printf comes from glibc. And things like main are not keywords. You can have a variable which is called main and no problem will happen. Main is a convention on the compiler side as a first function which is being run. Anyway, this was not a C lesson. This was a very quick review on all the C keywords, 32 plus a few. I'm thinking, and I think I will do this maybe very soon, to show samples of more specific things like cool usages of unions or volatile variables or registers inside the professional code. That's why when you study a book like this, which is old and classic, you never, I won't say never, but it's very difficult to understand the source code like a Linux. It's written in super advanced things. It's not, but it's difficult to start. I will try to record a video and show you some more advanced usages of C inside more professional codes. So you will see what's the difference between this C and that C. There is no difference. Only a little bit more experience. Have fun. I was Jody. Hope you enjoyed. Subscribe or do whatever.